Okay, back, and we're going to do some more examples of definite integrals because they're fun. So here's one you'd expect to see on a test. Integrate from 1 to 3, 3x squared plus 6x. I'd consider this one an easy one because it's not a u times du. It's not a function with an exponent on it. It's just two pieces of a polynomial. And so those are easier to integrate. And so why don't you try to pause and try that on your own and then compare to what I'm going to do. Okay, go. Okay, so the integral of this is going to be, let's see, this is just x to the n plus 1 over n plus 1, and x to the n plus 1 over n plus 1, all evaluated from 1 to 3. 3's will cancel, 2 will cancel and leave a 3 behind. So this is x cubed plus 3x squared, evaluated from 1 to 3. So it'd be 3 cubed minus 3 times 2 squared, times 3 squared minus 1 cubed minus 3 times 1 squared. So 3, 9, 27, minus 9 times 3 is 27, very convenient, minus 1 minus 3 times 1 squared is 3, so zero minus a negative 2, 2. There you go. That's the area underneath this function. Let's try another one. Oh, this one looks fun. Integral from 3 to 5 of x times square root of x squared minus 9 plus 2. Okay, so first of all, we're just going to rewrite it. We're not even going to think about anything. Right? Okay, so, well, this is a u to the n, right? This is a function raised to an exponent. And so this is going to be a u du kind of thing. But what do we do about this 2? That's kind of weird. Well, I don't know. Let's distribute the x through here. So it'll be 3 to 5 of x times x squared minus 9 to the 1/2 plus 2x dx. Now remember what this is, an integration is whatever function you have, we're summing all of these rectangles, right? It's a sum. We're adding rectangles together, but the rectangles are infinitely small and there's infinitely many of them because we are using dx really small. So this is a sum. And so there's two things I can do. I could break this up to go for an integral from 3 to 4, and then an integral from 4 to 5. It's like breaking up this into two pieces and adding up one part and adding up another part. The other thing we could do, since it's a sum, oops, hang on, let me get rid of this. Edit, cut, edit, cut. Since it's a sum, well, it's a sum right here. I know I can break this up because we've done this before. I could separate these two into separate integrals. And now this one is a nice, easy one. And now this one looks like a u to the n, right? So here I'm going to let me write it over here so I have space. Let u equals x squared minus 9. du is 2x dx. Do we have a 2x? No, we have an x. So I can stick a 2 in it as long as I take one away, as long as I divide it away as well. So now this one, 3 to 5, u to the 1/2 du plus integral from 3 to 5 of 2x dx. So this will be 1/2. Notice the 1/2, by the way, only operates on this one because this was the only one we were using u and du on. This doesn't get the 1/2 at all. So this is u to the 3/2 over 3/2 evaluated from 3 to 5 plus this will be 2x squared over 2 evaluated from 3 to 5. Now I need to make some more room. So we'll get rid of that. And we'll have to move over here. So the first piece of this is, let me get rid of that thing so it just doesn't end up becoming a negative sign. Okay, so this is going to be 1/2. The 3/2 will flip and become 2/3, and the 2's will cancel. U to the 3/2 evaluated from 3 to 5 plus x squared evaluated from 3 to 5. So these will cancel. So we're going to end up with 1/3 times, now what was u? I deleted it. Oh well. U was x squared minus 9. And I'll go ahead and do this one. This is going to be 5 squared minus 3 squared, right? Upper limit minus the lower limit. And the 2's canceled down here, right? Okay, so this is 1/3 times 5 squared minus 9 to the 3/2 minus 3 squared minus 9 to the 3/2 plus 25 minus 9. Okay, 1/3. 25 minus 9 is 16. 16 to the 3/2, 4, 16, 64. This is going to be 0 plus 16. So it looks like this comes out, did I get that right? Did I actually do it correctly? I did. 64 over 3, whatever that is, plus 16. So I saw this, I see this thing, and I know this is a u du kind of thing, but I had this thing is in the way. So because it's a plus inside the integral, I can separate it into 2 separate integrals. You like the special effects of that up there in the corner? Yeah, I know. So I can break it up into a more complicated piece and an easy piece. And then I'm able to apply the integration rules that we've learned and then evaluate the limits. That is some fun calculus. So there's things on the homework like this that you really, really, really need to do. And if you need help, you need to really, really, really ask me so that I can help you. We're going to do one last one. Which if I thought I wanted to put a question, not really a trick question, but a question to confuse you on a test, I would do that. But I'm really not into the coronavirus confuse your students' kind of mood anymore. So I'm probably not going to do that. So this is 0.25 x squared. Oh, hello, kitty. I don't know if you saw that on the camera. I'll have to go back and see. When she wants my attention, she will stand up and put her paws on me. If she's close to my face, she enjoys doing it to my face. I do not enjoy that in the middle of the night. Okay, here's the function. We want to get the area between x equals 0 to x equals 8. So those are our integration limits. So integral from 0 to 8 of 0.25 x squared minus x minus 8. Okay, there you saw her that time. What are you doing? Okay, so this will be 0.25. That'll be x cubed over 3, right? X to the n plus 1 over n plus 1. This is x to the first, so that'll be x squared over 2. And then this will be minus 8x. No plus c because this is a definite integral. It's definitely an integral. So we'll evaluate it like this. Anything cancel? Yeah, not really. So 0.25 over 3 times 8 cubed minus 8 squared over 2. That's an, oops, sorry, an ugly 2. Minus 8 times 8 minus, they all have an x in it, so they're all going to be 0. Beauty. Okay, so let me calculate these things. So I'll do this 8 cubed times 0.25 divided by 3, and of course I can do that in my head. And that is 42.67. I don't like to show off, but oops. Minus 8 times 8 is 64 over 2 is 32 minus 64. So if we crunch these numbers, oh, minus 0, we're going to get negative 21.3. And here's where it would be, I want to trick you on a test and confuse you, and hopefully you'll go back and you'll check the negative signs, because that's where errors typically happen, is on a negative sign error. And the reason why this one comes out negative is this function looks like this. And what we just found was, oh wait, since I know how to do it now, there you go. We just found this area here. And it's under the curve. So that's why it came out negative, because it's below the x-axis. And that's why we end up with a negative number right here. Okay, this was fun. It's the last example. So go through and look at your homework. Please do the homework. Please ask questions, because this will be on the final and it'll be fun. Thanks for watching. Bye.